Then we are going to stream this class and delete the other one because that was a train wreck. More than half the class decided to not do anything on Friday. You know what happens when you don't do the first half of a two-part lesson?
Doesn't work.
Nope. It does not work.
X squared doesn't have anything above is there P.
You tell me.
It would be more than
Come on now, that goes all the way back to algebra half. What is squared? What is 4p? Which way does it open? Label your axes. Your axes are going to have equations, not just numbers. P in both directions. What is your stretch or compression? How does that affect the rest of the dots on your graph? Remember, it's not enough to just have your axes, vertex, focus labeled. You need a couple of points so that you can show your compression or stretch for the parabola. Who's still going? Okay, finish her up. So y'all were in the Commons on Friday. Last 4 weeks updated, calendar on the back. I'm gonna keep it rolling all the way till the end. You are red. Plan on quiz 11 covering chapter 7 this Friday. Quiz 12 after another 5 days of chapter 6. I told you the last 3 chapters are fast. 4 or 5 days apiece. Because now we have the dubious honor of preparing you for 3 separate classes at once. Which is also, if you heard the announcements this morning, juniors. If you're a junior taking an ACT in June, right after this class, probably the most prepared that you're going to be for an ACT math section. Because we review so much stuff across a breadth of things. Traditionally, what happens is kids will take they'll take trig and calc, and because those are deep dives on a very specific subject, you forget how to algebra. Like today, what happens when we get to the problem where I say, how do you make a line between 2 points? How many of you remember that? If I just gave you 2 points right now, make a line between them. The equation of a line. Do you remember that? That was 8th grade for most of you. Okay? So if you're a junior, I would strongly recommend you sign up for that June ACT. Because that'll be right after this class. Everything's fresh in your mind. You're going to do good. Traditionally, it's the best that kids do, is right after their junior math. So, stage 1. This is not in standard form. There is a different kind of standard form for parabolas. We were used to seeing ax squared plus bx plus c as standard form. Okay? Standard form for a quadratic versus standard form for a parabola depends on which context you're talking about it. In this case, I need it to be in the form x minus h, the quantity squared, is 4p times y minus k. That's a standard form for a parabola now. Turns out there's a bunch of stuff about parabolas I never told you. Okay, this is like, waiting until episode 5 before Luke finds out, oh wait, Obi-Wan's lying, Vader's your dad. Okay, there's other stuff. I remember watching that. I was like 8, 9 years old. My mom's like on the couch behind me just waiting. No! Yeah. All right, I need to complete the square. I've got x squared minus 8x. Move all the not x stuff to the other side. And complete the square. I don't have to divide by an a value. So it's just add b over 2 squared to both sides. Which is half of negative 8 is negative 4. Negative 4 squared is plus 16. The standard form of this particular parabola is going to be x minus 4, the quantity squared, is y minus 2. And I do leave it like that. Okay? Now, what is the 4p value? 1. But what I don't do is put a 1 right there. Now, I might need to do that as I'm working to help me remember that the 4p value is 1, but it's not the simplified form of the equation. Okay? So, you got that. Cool. Which way does this parabola open? Up, down, right, or left? Because it's an x squared, I know it's vertical. Because 4p is positive, I know it opens up towards the positive end of vertical. So there's a parabola. I'll just do generic parabola sketch with a focus, vertex, directrix, axis of symmetry, and we'll start throwing things on there. So, where's my vertex? HK, bass backwards land, 4, 2. 4, 2 is my vertex. How do I find my focus and directrix?
Plus and minus.
You got to P both ways. Whatever 4P is, in this case 1, divide that by 4, my P value is 1/4. So I'm going to go 1/4 north of that, 2 and 1/4. So 2 and 1/4, this is up at 4 9/4 is my focus. I'm going to go down 1/4 from there. So my directrix is a line, it's a horizontal line, so y equals 1 3/4 or 7/4. My axis of symmetry is the line that goes north and south through those, and you notice that the x values are the same. So my axis of symmetry is x equals 4. You cannot just say 7/4. You cannot just say 4. Y equals and x equals, and which one's which matters. And then, to finish it off, remember that if I were to rearrange this, it's just my vertex form of a parabola. And the a value is 1. Because my a value is 1 over 4p, because I'm going to have to divide over to the other side. So that means it's got a normal stretch or compression to it. Normal perfect square steps. So from that vertex, you got a choice of which set of points you need to have. But you got to have something to show the stretch or compression to it. From this vertex, I'll go right 1, up 1. I suppose if that's at 1/4, this is like, whoop. Okay, right 1, up 1. This is very not drawn to scale. So 5, 3. And then it's compatriot over here at 3, 3. I would have gone right 2, up 4. So I'd be way up here at 6, 6, or back here at 2, 6. Or I'd go right 3, up 9, back 3, up 9. So you would have had the next set, or the next set, or the next set. Okay, depending on which values you used. At a minimum, you need something out there so you can show the stretch or compression. If you had your vertex and from there you did 1, 1, dot, 2, 4, dot, dot, you're good because you have it on a grid. You have it on graph paper going by the particular scale with those points. This is for anyone who's just sketching it. Okay, if you're just going to sketch it, then you have to put numbers there to show the stretch or compression. So, stage 1. Did you complete the square and put it in the right form? Stage 2. Did you show a parabola opening upward? I'll have kids who find the correct vertex, they got the 4p value right, and then they just go in completely the wrong direction. They're Forrest Gump running for the wrong end zone. Everything perfect, but the wrong way. Okay, so that's a point. Next up, your vertex and your axis of symmetry are going to go together because your axis of symmetry just goes through the vertex. Your focus and your directrix are going to go together because you P'd in both directions. And then, whether you made a bunch of accurate dots on an actual graph or labeled something on your graph to show the stretch or compression. Okay, so got to the equation, headed in the right direction, Vertex and axis symmetry are right. Directrix and focus are right. Got some points on there to show it was actually by base 1 for your square steps. Okay. And all those years later, you find out, wait a second, there's more stuff about parabolas? So, I was only asked one question in the last 96 hours, or whatever it was. So, speak now or forever hold your pieces. Okay. No, bad Frank. All right, words. Well, I got a parabola. Okay, vertex of the parabola meets stern of the boat. Gotcha. Swimmer on the wakeboard. Blah 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 blah. Here's an equation. Write the equation in standard form. In order to do that, I need to put stuff that is squared and associated with it on one side, everything else on the other. So since y is the thing that's squared, I'm going to put the y squared and the plus 10y on this side. I'm going to move everything else to the other side. 180x minus 565. I'm going to complete the square. Half of 10 is 5. 5 squared is 25 plus 25, making that 540, which comes out as 180x minus 3, right? And this side as a binomial squared, y plus 5, the quantity squared. I have to be able to complete the square. You completed the square in Algebra 1. You probably didn't do it again in geometry. It was available to you to solve quadratics. You did it again in Algebra 2. We reviewed it again at the beginning of this class. Well, guess what? This is the chapter where you got to do it every day. Sometimes twice in a problem. Okay, I'm there. Write the equation. How long is the length of rope attaching the swimmer to the stern? What are they asking for?
Vertex P.
They're asking P. The distance from vertex to focus. So, take this divided by 4. This is 45 feet back. Ta-da! Okay. But you got to be able to complete the square. Others? What you're going to find with the 3 sections of this chapter is that each time they're going to start with, here's the equation. Tell me the features of it, like by graphing. And then on the back half of it, they're going to swap over to, here's the features, tell me the equation. So you're going to go backwards. So, here we go. You see how if you have no idea what happened on Friday, you're just like, what is this?
What did you do last class?
I stayed home and looked after my kid.
I meant like first period.
I went through it and I just said, screw the whole lot of you. If you didn't do what you were supposed to and you had 3 days to do it and you didn't do what you were supposed to in class, that's your fault.
3 days in class.
So, stage 1. I'm just going to sketch some stuff out. If I have a vertex at 1, -4, and a focus at 3, -4, is that up, down, right, or left of that thing?
Up. Right. Left. Left. To the right.
All right.
Right too. It's right too.
X's
Right.
go left and right.
The focus
Y's go up and down.
right. The vertex is left.
Okay. The focus is 2 to the right of that. Man, this does feel like my freshman algebra. Now that I have that, does my parabola open up, down, right, or left?
Right.
To the right. It always opens up towards that focus. Now I know that satellite TV is a dying breed. Everything's just streaming now. And that's just in the last 10 years or so. Everything's just kind of trailed off. But how many of you have that satellite dish still on your house? Or at least your neighbor does or something. Okay? Or maybe you've seen the old movies where they've got the big headphones and they got the shotgun microphone pointed at someone like 15 blocks away and they can still hear everything. It's because of this focal point. The idea is things come in, hit dish, go to focal point. Things come in, hit dish, go to focal point. There is a point where all of the things coming at it will bounce off and congregate. Okay? Yes, pew pew. Okay? Well, that focal point is going to be in the center of that parabola where it collects all of that. So, I'm going to draw a generic parabola headed to the right. It doesn't have to be a work of art, it's just got to go that direction. I'm going to draw my axis of symmetry through those vertex and focus. I'm going to draw my directrix back behind it. And then we'll start writing in information. If I've got a parabola opening to the right, what is squared, x or y? Okay. So I know y is squared, x is not. If I know my vertex, then I know my h and k. H always goes with x, backwards. Y always goes with, or k always goes with y, backwards. And then, to find the focus, I p in that direction. So if p is 2, then my 4p value in the equation, is it positive or negative 8 though? Because it's opening towards the positive side of the graph. Okay, now if I want to graph the rest of it, it says find the equation and graph, and I can just sketch it, that's fine. I'm also going to go in this direction. I've got a directrix at x equals, because it's a vertical line, 2 back from 1, negative 4, is at negative 1. My axis of symmetry, horizontal line, so it's y equals, it goes through 1, negative 4, 3, negative 4. You notice the y's are the same, so y is negative 4. And if I wanted some more points in there, remember that my stretcher compression, 1 over 4p. So in this case, my stretcher compression is 1/8. Now I can make more points on there by fractions. I know you don't like them, but up 1, write 1/8. Up 2, write 4/8, or a half. Up 3, write 9/8. Those are all fractions. Maybe we don't want to do those. So you can always pick a perfect square that is divisible by 8. Okay? So what I would do is go up 4 over, not 16, 2. So up 4 from here is 0. Right 2 from there is 3. 3, 0. Mirrored down here, down 4, right 2 is going to be at 3, negative 8. Now again, that's if I'm sketching it, I need to put a labeled point or pair of points on there to show my stretch or compression. If you're graphing this on actual graph paper, you just count the boxes and put the point in the right spot. Okay?
Do we always put the 4p value before the side that's not?
Yes. The thing that's squared is by itself on one side. They don't always give it to us like that in an equation. We have to rearrange it. Okay, so they're going to give us some information. We have to make the equation. I got a vertex at -2, 4. I have a directrix, y equals 1. Is that up, down, right, or left from this vertex?
That's down.
Okay, getting a little better this time. Can't just go with one person, right? All right, so if I've got that, then will this open up, down, right, or left? Up, right? Opposite of the directrix. I also know, because my axis symmetry went through this vertex and it's vertical, my axis symmetry is at x equals -2. Since this thing opens upward, what is squared? X's for vertical. So x squared y thing. In there I plug, well, I know my vertex, so I got h and k. X minus a -2 is +2. Y minus 4. And then, fancy that, the distance from my vertex to my focus is also the distance from my vertex to my directrix. 3. Now remember, this 4p value is 4 times that distance. So, 12. Positive or negative? Positive because it's opening upward. And then again, if I needed more points, my a value is 1 over 4p. From 4 to 1. Uh-huh. This is p, this is 4p. Y minus k, x minus h.
No,
And it comes from completing the square. You'll notice in the quadratic formula you have a 4ac in there. Okay? I didn't go through the proof of it last semester, that's why it wasn't in the video, but you can rearrange the form of a parabola in vertex form to make this by completing the square. That's where that 4 comes from. Okay? So if I have a 1/12 compression, again, I want to use perfect squares that are divisible by 4 if I can. What's a perfect square that's divisible by 12? So normally I'd go over 3 and up 36. But now I'll go over 3 and up 3. 1/12 of that, 36. So from here, I'll go right 3, up 3. So that's going to be at 1/7. I'll go left 3, up 3. This will be at -5/7. Wait, over 6, not 3. Whew. Mental math no good today. Very no good. Right 6, up 3. There we go. So that's at 4, 7. Back 6,
It'd be
up 3.
yeah.
Negative 8, 7. Whew! It's close. They got me twice last hour. What's up?
Do you want us to write F then?
Oh, yeah, your focus. Go 3 in that direction, too. So 3 north of this guy is at negative 2, 7. And now we have double parentheses because why not? Before moving on to example C, because it's a completely different animal, I want you to do 4A, 4B.
So H first. Okay.
H goes with X. K goes with Y. Think of it as alphabetical. X, Y, H, K.
That's like 10 minutes ago. Yeah.
Yeah, that bass backwards. Mental math has not been my thing this morning, so check me. Okay. You can gain a lot of information from just 2 points. Parabola always opens towards its focus. Horrible. That's a little better. If you know a focus and a vertex, you know an axis of symmetry, you at least know the direction of the directrix. Okay, so I haven't done any actual math yet. That's just, I was given this information, I know what that information does, because I know where those things are on a parabola. Can you finish it off? Okay, the distance from a vertex to a focus is p, and you p in both directions. So I have an axis of symmetry going through those at x equals -6. 3 south of this is a directrix at y is -4. Axis symmetry goes through focus and vertex. If I p in this direction 4, then I'll p in that direction 4. 4 to the east of 9, -2 is a directrix of x is 13. Okay. Just that distance between focus and vertex gives you a lot of information. Tells you the p-value, tells you how far back to the directrix, or vice versa. If you know to directrix, then you know to the focus. If you know your vertex, then you know h and k. If you know your vertex, you know h and k. They're grouped in parentheses with a variable, so they're always backwards. If you know the p-value, then you can find the 4p value. If you know the p-value, you can find the 4p value. Whether it's positive or negative just is whether you go north or south, whether you go east or west. Right now, anyone who has trouble with basic directions is having problems. If I tell you head north on Highway 85 and need you to turn west at mile marker 218. If that is just gibberish to you because you want, okay, go out of town towards the overpass, you need to go past the 9 fascist flags, get to the bottom of the hill, and then you turn left once you go over the creek. But make sure that you do it before the blue mailbox. That person is having a hard time right now. Okay? Because there's a property owner who every quarter post he puts out a bunch of fascist flags. Yeah, all along North 85. Drive towards Bell. Okay. So Bell. right? So once you got those, are you okay finding more points with them though? A compression of 1/12, a compression of 1/16. Okay? So those aren't such a big deal. This gets to be more of a deal. And to do this, we're going to need to do a little bit of a side quest. Whoop, 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 whoop. Back to Fridays and the very definition of a parabola. The definition of a parabola is a locus of all points. Locus is a grouping, a set. Okay? Have you heard of intrinsic versus extrinsic locus of motivation? It is the grouping or set of things that motivate you. Intrinsic motivation. I can do it because I want to. Extrinsic motivation. I will not do my work unless you give me points for it. There's a reason that your homework and notes are worth only 10% and as completion only. Because I've done the math, and the difference between a kid who does zero work and a kid who does every scrap of work is only 4%. I'm willing to give up that 4% if it makes you just do something. So, this is a locus of all points. It's a grouping of all the points such that this distance, specifically from a focus to my point, is the same as that point back to my directrix. That is the same, no matter where. So that distance could be, what if I had a point here? Well, if I measure from here to here, it's the same as here to here. They're the same. I may not always draw them the same because, well, artistic skills be damned, right? Those distances will always be the same. So if those are distances that are always the same, perhaps we need to know how to find the distance between any 2 points. That's a comma, not a 1. Okay. Yep. Distance formula is just rearranged Pythagorean. Good thing we didn't try to do anything with it yet, right? Distance formula is the rearranged Pythagorean. How long is this leg? You're like, no. X2 minus X1. Remember, if this was a 12 and that was a 7, you would do 12 minus 7, right? Count boxes from 7 over to 12. 12 minus 7. So this distance can be written as X2 minus X1. So what's this distance? Right? If I ask what is the difference in heights between Logan and Alexis, you subtract, right? So I take y2 minus y1. I used to have a kid in class that was actually her nickname. A little bit. A little bit. So the hypotenuse of this thing is, well, the square root of leg squared plus leg squared minus. That's my distance formula from way back in geometry, like first chapter of geometry. Now, could I also just have this on my paper, count boxes, and do Pythagorean? Yeah. But do you always have it on graph paper where you can count boxes? Nope. So take your pick, right? You're either going to use a formula or you're going to do Pythagorean. Another thing you should probably be aware of is Pythagorean triples, because boy, do they love using Pythagorean triples on these problems. The first one, 3, 4, 5. The second one, 5, 12, 13. The third one, 8, 15, 17. There are more. In fact, I remember about 10 years ago, I want to say it was Caltech. They used a supercomputer running full speed for like a month to actually find a new set of Pythagorean triples. Because every Pythagorean triple that you find when you go further on can be reduced to one of the previous ones. And they found a new set of relatively prime Pythagorean triple numbers. But those are the three that you're most often going to find. And then they scale them up. So instead of having a 5, 12, 13 triangle, maybe the distance between your x's is 10. The distance between your y's is 24. Well, since 10 and 24 reduces to 5 twelfths, I know it's a 5, 12, 13 triangle. Okay? So if you know that, it can help you, maybe save you a little bit of time. So again, that distance is this distance. I'm going to use that when I'm given certain information to find my parabola. Parabola opens left. Draw parabola opening left. With a focus here, a vertex here, a directrix here. This is very not drawn to scale. That's okay. Not drawn to scale. All right, parabola opening left. Check. Focus of 2, 1. Check. Contains the point 2, 5. Where is that from this focus? Straight north. So it contains the point 2, 5. Which means I actually don't need my distance formula this time. I can just count boxes, right? But that's the catch. Here, you come down here, you come down here, you come down here. I work at Burger King, making people Whoppers, paper hats. That distance of 4 is also the distance back to my directrix. Not drawn to scale. So, what's 12 to the right of 2, 5?
Say that again.
What is 4 to the right of 2, 5?
2 9s.
6, 5. No,
Oh no, it's 6 5.
X's move left and right. Y's move up and down. What is 4 to the right?
6, 5.
6 5.
To the right.
6 5. I think we might need a song to remember.
Bruh.
X's.
Okay, so this is at 6, 5, which means my directrix is at x equals 6, and my axis of symmetry, y equals 1, the y value of the coordinate it goes through. So this point, it's not a relevant feature of my graph, but it is where my axis of symmetry and my directrix meet, is where we're getting there. Since I p in both directions, from my vertex to my focus and my vertex to my directrix, that means that my vertex is the midpoint of those two. What is halfway in between 2 and 6?
I was thinking
Boy, we're having a time here. 4-1. I know. Okay.
For me, it is.
So when I see opens left, I know I'm going to have y is squared. I now know my vertex is 4-1. So h is 4, k is 1. What else do I get now that I know the midpoint of that set of pairs? I know that we're going to p in this direction too, and we're going to p in that direction too, which means this is 4 times that, positive or negative, because it opens to the left, to the negative portion of my graph, -8. Do you see where that would have been dicey if instead, what if that point is out here? And I can't just count boxes. Then I need to either make a triangle and do Pythagorean, or I need to use my distance formula. Okay? And that's what the other two are. Get them both. Get that hustle. X negative 5, 8, 6, 10, 10, 10 north 0, 0. 4 is 2 is
Yeah, that's gonna be a really small theta. Big T down.
And then you have to do right there, and then you have to do the distance.
right distance 5, 9, 9, 12, 15, 15 left, -7. 5 is -4. Check me before I wreck me.
So the triangle goes to the focus point
Yep.
and the directrix? Or the
No.
vertex?
Did you find this distance yet?
No.
Make your triangle right here. Because
So,
you're trying to find this distance by Pythagorean or distance formula.
okay, so it's this, like that's
No.
the triangle?
No.
Oh, then what's...
This distance.
Oh.
I'm trying to find this.
Okay. Okay.
There you go.
Today is a Monday.
Do we use the distance formula for this?
Uh-huh.
We did that. I don't know our answer. What did I do wrong? I typed it in right.
5 minus -3.
Oh, well, I wrote that down.
I was kind of zoned out the last 10 minutes.
Okay. Then.
Both of these distances are integers because they're Pythagorean triples.
Let me try that.
It should be this hard.
Where did you? Oh wait, I'm sorry. I did this
On Friday, we went to the King store and we went to go get pizza. And it was like at what 8:30, and so we made the quickest trip down to Little Caesars. So I've never seen. We saw Ken in there. We walk in. He's just like, "Yo."
Good story, bro.
Walked in, we're like, what do you got hot bread? Took 7 negative 4 for that.
Where did you get negative?
I thought I heard you say negative 10 minus 4.
Negative 10 minus 4.
Yeah.
That's some dudes that want to say 2 orders of ways, which you don't have hot
They're not. We don't.
Yeah.
That was ready after like 7.
This is going up or down. That one's going left or right. We're changing the Y this time.
Oh, yes.
Okay. I gotta review.
Oh, yeah. And this is a Pythagorean. Because it's, yeah,
Vertex negative.
So what do you do when you find a distance?
The distance from point to focus is the distance from that point back to the directrix. Because that's the definition of a parabola. Then you didn't use parentheses on your negatives. Lies. Do I get more cookies?
Sure.
Yeah. Oh, they're finally dying. Okay. All right. We'll charge it tonight if someone reminds me. Okay. I'm missing 3, the quantity squared plus negative 10 minus negative 4.
Oh, it's negative 10. What? I did the rest. Pretty sure it's
Not. Oh no. D's 10. For what? Distance. Okay, no. For the first one, the 2 that's attached to the Y. Is that not supposed to be 1? Not to do.
I don't know. Let's find out because I didn't in my head and I don't trust myself. So 10 north of this. 5, 0 makes this point negative 3, 0. Makes the point halfway in between them negative 3, negative 2.
Wait. Why did I?
Okay, before going on to the second one, sounds like we're having some problems here. Stage 1, it opens down. I'm going to make a generic parabola opening down. Doesn't have to be drawn to scale. Don't care. Purple, generic parabola opening down. Has this focus, contains this point. Focus, negative 3, negative 4. I'll start there so that I can say that my contained point is right and down of that. Recognize the Pythagorean triple or use your distance formula. When I say recognize the Pythagorean triple, y'all, if I just make a triangle out of this from 5 back to -3 is 8. From -10 to -4 is 6. 6 over 8 reduces to 3 over 4. The legs of the triangle were 3, 4, so the hypotenuse is 5. They were twice as big, hypotenuse is twice as big. Or dump it in my calculator and get the distance formula. Okay? When I find that distance, if it's 10 from the point to the focus, then it's 10 from the point back to the directrix. So 10 north of 5, -10 is 5, 0. That makes my directrix y equals 0. The intersection between my directrix and my axis symmetry is at -3, 0, and my vertex is halfway in between there and my focus. So if I got my vertex, I've got my h and k. Because it's opening downward, I know that x is squared and my 4p value is negative. The distance from my vertex to the focus or my vertex to the directrix is 2. 4p is 2 by 4. How do we do with contestant number 2? Okay, finish off 2. Let's check that again. 4 right, 9, 12, 15, 15 left. -7, -7, -1, midpoint, -4, correct. 5, correct. Opens right, so y squared, yes. From -4 to -1 is 3. 3 by 4 is 12. Yes. Okay. Good talk.
Okay.
No, they don't. You can't even.
They do not have to be a work of art.
Okay, yours are always a work of art.
Wrong because I plugged this in and I did not get 10. Is this like the wrong equation?
5 minus
Or
-3.
it's like this.
-10 minus 4. Well, that's... Where's your other parenthesis?
Oh, well, yeah. Is it going to give me the wrong answers? I didn't have the other parentheses.
Well, you gotta parentheses the whole thing.
Well,
Oh.
because otherwise you're only squaring the -3 instead of the result of that difference. Maybe we'll write it over here on the board. Okay, wrote the distance formula over here with all of the parentheses intact. Okay, maybe the parenthesis thing is more simple or more relevant for me because back in the day, y'all, I never had a right view calculator or a graphing calculator until my second or third year of teaching. I did everything on the old school ones where, yeah, it had parentheses, but it never showed them. You just had to remember where they were. Kind of like that's even worse than the Lamo calculator that's on your phone. Okay, we had to use parentheses. So use parentheses. See if I can find it.
Subtract 15.
Where are you, old friend? That. That was my calculator from 7th grade through 5 years of college into my 2nd year of teaching. It has your trig values, it has your reciprocal, it has your radicals, it has parentheses. You just had to remember where everything was as you were typing because it didn't show it on the screen. This one, I finally gave it away last year. I had kids in my inclusion algebra who didn't have a calculator, so I just gave it to them.
I thought it would be like was it the same calculator?
Yes.
Oh, I thought it was.
No, it was the same calculator. It was just
The chosen one.
it was a calculator. Okay. Opens right. Generic parabola to the right. Axis of symmetry. Directrix, vertex, focus. It tells you there's a focus, -1, 5. It contains the point, 8, -7. It's another 3, 4, 5 triangle, except in this case it's a 9, 12, 15 triangle. If that distance is 15, then this distance is 15. If it's 15 back from this point, then this point is at -7, -7. Which means my directrix is x equals -7. Which means the intersection of that with my axis of symmetry, x equals, or y equals 5, is the point -7, -5. Halfway in between -7 and -1, add them up, divide by 2. Y'all remember that? Why did I put a negative? Probably because this was trash. Okay. Your midpoint formula. Y'all remember midpoint? Okay. Halfway in between -7, 5 and -1, 5 is my vertex at -4, 5. It opens to the right, so y is squared, 4p is positive. You got your vertex, hk, plug them in. If you know that distance, you know p. If p is 3, then 4 times it is 12. Okay. So what I got out of last hour from the kids who actually did stuff is if I'm given the vertex and the focus or the vertex and the directrix, basically vertex and thing, I'm fine. But as soon as we do this contain stuff, starts getting a little hairy. How we feel about the contain stuff? Is actually good, or I don't want to do it?
We should do one more. I do feel good, but I also don't. We should do.
Come on, you. Again. You're going to have to go by a scale of 2 if you want to fit it. Yeah? Right. 8 contains 5, 6, 8, 10, 10 south, 10 back, -2, 0, 0, 1 right. X4 to 8.
Put the parabola on the.
You can either sketch your own or you can use this space. You'll have to go by 2s. It's your choice. Ain't bad. Not bad at all.
You want to try one of the batch 1 cookies?
Not really.
There's so much flour. Because the recipe I used, so I was reading off the recipe and he said, it originally had nuts in it. I was like, no one likes nuts in cookies. And then it was like, if you're not going to use nuts, add an extra cup of flour. And I was like, okay, added the cup of flour. And then I was like, shoot.
You should do the problem.
I should do it.
It's a little messy.
I didn't see the top half of the parabola. I was wondering why yours was sideways.
Yeah, you're right. It is. I was going crazy. So the 3 and 4 is 3. Oh, did we just change this? So X is
Oh, wait. How's the focus? Not a vertex. Careful. There we go. Okay. Focus at 2, 1. Contained point, 8, -7. What's the distance between those two? 10? So here's my axis of symmetry. This is 10. That tells me go back 10 to my directrix. So if my directrix is 10 west of this point is at -2, -7. My directrix is at x equals -7. My axis of symmetry is at y equals 1. The intersection between those two is the point -2, 1. And halfway in between -2, 1 and 2, 1 is 0, 1. So if I have a vertex of 0, 1 opens right,
Wait, wouldn't it be, wouldn't x equals
oh, yeah, there we go. I just got my x's and y's swapped up. Oops. Probably happens when your 2's get lazy and look like 7's anyway. Okay. If it opens to the right, I have a vertex of that, and then I have a 4p value of, I just found out, p is 2. Opens right. Y is squared. Vertex of 0, 1. I know k. Technically, there's a -0 here, but you don't write it because that's not simplified. If you need to put it there as you're working, that's one thing. But I don't put it there as my final answer. And then if the p-value is 2, then 4 times that, get 8 as my final answer. Now, here's where kids go a little cross-eyed. The definition says that this distance is also the distance back to my directrix. I can use that distance a different way for the next application. The next application says that distance, if I go back along my axis of symmetry, gets me, and it doesn't even have a name. It's just this special point. Okay? It's special point. Last hour they decided to give it a name because they felt bad for him. They called him Chester. Now, the reason that we go back along that axis of symmetry, that same distance, to find this is because that's what's going to get me a line of tangency. Up here. A line of tangency is, do you remember back to, probably not, because anytime I mention geometry, the answer is no. Do you remember with circles, you had tangent lines? And secant lines? Okay. A tangent line is a line that skims across it and hits it at exactly one point. So think about if I were to zoom way in on that. Let's say that's your head. And I pull out the Nerf gun and, well, if I get you with a tangent line, skims right by you. We call this plot armor. It goes right by you. Versus a secant line, first matrix, dodge this. Splat. Okay? A tangent line has to hit it at exactly one point. And it can only happen in one specific spot, because if I tilt this just a hair, if I change the slope on it just a tiny bit, what happens? Now it doesn't just skim your hair and leave a little, now it takes part of your skull with it. Okay? Case in point, how many of you have touched a human skull? A human skull?
Technically, we all have because we're touching our own.
No, the skull itself.
The skull itself? I am not.
Why have you touched a human skull?
No.
How about of a living person?
What? Lifeguard hasn't got that bad.
Okay.
Sullivan's living some weird second life.
It was a thing. It was a thing. It happened. No, because we have 5 minutes. The point of tangency is that one magic point, that one perfect slope at that point, where it's going to go back along that axis of symmetry, and you get that perfect point. So that distance between these two is also going to go back along here, and it only happens at one magic spot. So, stage 1, if it's not already in our standard form, make it in standard form. Y squared is x minus 3. If you need to write that in a different way so you can tell what the crap's going on, then by all means, do so. Okay, purple is actual standard form. Blue is how I wrap my head around this. So I'm going to start with a vertex at, where is that at? 3, 0. And it says it's going to hit the contained point of 7, 2. Is that up, down, right, or left from that? I'm just throwing it in the middle of the graph, so that I got room on all sides to make my parabola and this line. 7, 2. Up, down, right, or left?
Right and up.
Right and up. 7, 2. 1, 2, 3, 4. 1, 2. There's my contained point. 7, 2. I should probably take this and move it down here. Oh, you rat. There we go. And if I've got that, well then, if this is an axis of symmetry, 2 above it, I can make another point 2 below it to make my parabola. Okay, so I rearrange it, I make a parabola, graph whatever parts you need to, put the contained point on there. Next up, go find your focus. How do I find the focus again?
1p.
I p in both directions. Right now, what is my 4p? So what is 1p? 1/4. So if I go 1/4 to the right of this point, it's not very far, I've got a focus of 3 1/4, or 13/4, 0. I want to stay in fraction town for a reason. It's because of how my distance formula works out. You got to find the distance between those two. Now, most of us are just going to head to the calculator. Use parentheses, type it in as a fraction. If it's a fraction, your calculator will tell you. If not, you're going to go old school and say 2 minus 0, the quantity squared, plus 7 minus 13/4, the quantity squared. Getting square root of 2 squared is 4. 7 is 28/4, minus 13 is 15/4, squared is 22/25/16. 4 in terms of sixteenths is 64/16. 64 and 225 is 289/16. Here's why I want to do it in fractions. 289 is a perfect square. 17. That distance is 17/4. Why would I care that it's 17/4? How is that somehow helpful? This is 13/4. They have the same denominator. It's going to end up working out nicely. They arranged it in such a way that it's going to work out nicely. If I move back 17/4 from 13/4, where am I at? What's 13 waffles minus 17 waffles? -4 waffles. -4/4 is -1. So if I move back 17/4, or 4 1/4 from here, that's 1, 2, 3, 1, 2, 3, 4 1/4. There we go. I'm back at -1, 0. Why would I care that that point is nice? Because we're going all the way back to algebra half, pre-algebra. Do you remember how to find the equation of a line between 2 points? Slope is y2 minus y1 over x2 minus x1 is 2 minus 0 over 7 minus -1, 2 over 8, y minus y1. Please tell me that you remember basic algebra 1.
The past 2 years.
You have to be able to find it. Basic algebra 1. We'll start tomorrow with another one of those. Talk to Logan.